Okay, it's the final week of this module, and this week I'm going to do 4 reasonably short videos about things that can go wrong with fMRI analyses. Each of them is its own set of problems. Each of them are real-world problems. They're not things that we're sort of making up, even though occasionally they sound a little bit crazy. In particular, the first one I'll do is quite a good example. It's a little bit nuts. Having said that, I think that this is the end of what I would consider the really practical parts of the module. And that is to say, not only do we have to think about how do we interpret the data, but what are the things that we can do wrong that are potentially problematic. Now, obviously, there's any number of technical things that could go wrong throughout the whole process. And I assume that those are reasonably obvious. That's why we went through the process of how we do pre-processing, how we set up models, how we do inference, etc. These are more on the interpretation side. These are how to do things incorrectly once you have your results, assuming they're all perfectly fine in terms of telling the story of what your data actually say. So my aims today are to talk about uncorrected statistical thresholds, that is overly lenient thresholds and the problems that they pose. And of course I need to situate that given the context that I've already provided last week. I'm going to talk about a thresholding fallacy, a way of thinking that you found a real difference when maybe the data don't actually support that. Some of the problems associated with region of interest analyses. And then finally, and perhaps the most prevalent of all of them, is the question of reverse inference. How do we infer cognitive or emotional state from brain data? And what are the issues associated with that? It's a very, very common practice. So perhaps the most sort of crazy example that I want to go through is what's now colloquially referred to as the dead salmon experiment. And this is an issue that is associated with very lenient statistical thresholds. So to just contextualize this, last week I said, when I look at my data, I first start by looking at the sort of raw, unthresholded images, and then I look at them using very lenient statistical criteria. I stand by that. I think that that's exactly the correct approach when you're trying to understand what's in your data. That is absolutely not the correct approach when you're reporting your data in a formal situation, whether it's being reported at a poster at a conference or in a talk or, critically in an article that you're writing for a journal. That's the point where the data have to be able to stand on their own. And at that point, using lenient statistical criteria is precisely the wrong thing to do. The dead salmon experiment was a way to illustrate this. So what did they do? So there was a bunch of researchers in the States who went to the grocery store, bought a whole frozen dead Atlantic salmon from the grocery store and brought it back to their MRI suite, put the salmon in the scanner and, set everything up correctly, got everything going. And then they played their very favorite sort of social experiment, which involved showing the salmon pictures of people in social situations. And the salmon's instructions were, imagine, if you will, the emotional state of these people. So for instance, you see the women in this picture who are clearly at a party, they're smiling. I would imagine their emotional state is that they're very happy, right? So it's a social emotion experiment that this dead, frozen solid Atlantic salmon is being asked to do. And what they found was that there were a couple of small areas of activation. And what was remarkable was that these areas of activation were in parts of the limbic system of the salmon. Now, traditionally, the limbic system is one of the parts of the brain that's very strongly emotionally sensitive. That is to say, parts of the limbic system are very, very sensitive to emotional processes. And what do you conclude from this, right? So there are more or less 2 possibilities here. One is that this is quite remarkable and that they've somehow figured out that this X salmon was capable of successfully attributing emotional states to pictures of humans that, I think it's safe to assume it probably had never seen before. Or you could take from it the point that they were actually trying to make, which was that by using lenient statistical thresholds, you do get false positives, and false positives are easy to tell a just so story around. Now, this was interesting for a couple of reasons. First of all, when they did it, there was a real issue with a lot of journals accepting fMRI studies that used uncorrected statistical thresholds. That is to say, too lenient. They weren't correcting for the multiple comparison problem. They were sort of bumping it up from 0.05 to something like 0.001, but nonetheless, the chance of false positives is still approaching unity in this. I mean, they're going to be there. But people were saying, hey, this corrected thresholds were a little bit too strict. We need to do something better. And hey, we get meaningful results. Look, I can tell a good story around it. Sure you can. Everybody can. It's called a just so story. And the just so story with the salmon is that it's absolutely remarkable that this salmon is able to correctly identify emotional states in human beings. That doesn't make it right. And I think we could probably agree that it's not right. The other thing that was very, very clever about this is that you might be surprised to discover that salmon don't have the most sophisticated, most complex nervous system. Most of what they have could arguably be considered limbic cortex. So if you saw anything in parts of the salmon nervous system, it's almost certainly going to be in limbic cortex. So that was kind of the genius of this study. By choosing a salmon rather than some other dead and frozen creature, one, they could get it from the grocery store, and two, if they saw anything in their lenient statistical thresholding, you could attribute it to limbic activation, which has been in many studies associated with emotion. So what was brilliant about this was, despite the fact that people knew that lenient statistical thresholds led to incorrect false positives and these kind of just so stories, they were incredibly prevalent in the literature at the time. And, you know, we've all had statistics classes. We've all talked about thresholding and why we have corrections for multiple comparisons, etc. Nonetheless, that kind of just the facts didn't really reach people in the same way that this did. What these scientists did was illustrate a really strong principle that advertising and marketing people have known forever, which is that when you give people information in a sort of factual form, they kind of get it. When you put it in a narrative and make it a little bit of a story that they can engage with, they really get it. This is what this group did. Now, in fairness, they won an Ig Nobel Prize for it. And I would say that this is one of the examples of an Ig Nobel that makes you laugh and then makes you think, because it is a wackadoo thing to have done, and it's pretty funny. However, it has a really strong, serious message there, and it's a message that actually did influence the community, and it affected a ton of editorials, editors at different journals in terms of what they were willing to accept in terms of the criterion of functional imaging data. And amusingly, it affected reviewers too at the time. I remember anytime you saw somebody trying to report uncorrected statistical thresholds, you often got the phrase dead salmon in the review, and that was pretty much the kiss of death. So it did make a difference, and it was a very powerful and often cited study in functional imaging. The key message here is you do need to correct for multiple comparisons whenever you're reporting your data. That doesn't mean that you need to do that when you're looking at your data, okay? That's the distinction that I want to draw here, and I want everybody to be familiar with the value of the dead salmon.